And in fact, one of the things I'm trying to do with this idea of like trying to actually quantify the origin of life as a transition in like a phase transition in assembly theory is actually be able to explain why that boundary is where it is. We define something we call the assembly universe, and the assembly universe is ordered in time. It's actually ordered in the causation, the number of steps to produce an object. And so all objects in the universe are in some sense exist at a layer that's defined by their assembly index. And the size of each layer is growing exponentially. If you want to look at the long way of getting to an object, as I'm increasing the assembly index of an object, I'm moving deeper and deeper into an exponentially growing space. And it's actually also the case that the sort of typical path to get to that object is also exponentially growing with respect to the assembly index. And so if you want to try to make a more and more complex object and you want to do it by a typical path, that's actually an exponentially receding horizon. And so most objects that come into existence have to be causally very similar to the things that exist because they're close by in that space, and they can actually get to it by an almost shortest path for that object. Yeah. We're this kind of recursively like stacked structure of like all of these objects that are clinging onto each other for existence, and then they like grab something else and are allowed like able to bring that thing into existence because it's kind of similar to them.